Alright, so continuing on collection types, this video I'll be covering dictionaries. So what are dictionaries? Dictionaries are they are very similar to arrays. Really the differences are, one, there's no defined ordering at all. And then two, instead of having an index, a dictionary has a key. So you search for the value by the key, unlike arrays where you search by the index. Alright, so I'll be covering how to create dictionaries, so dictionary literals, accessing and modifying them, as well as removing the key value pairs, iterating over a dictionary, so going through it, through each key value pair. And then I'll do kind of a special little video. I don't know if I'll include it in this one. I probably won't. I'll probably just tack it on, or it'll be a totally different video. I haven't decided yet. But basically I'll cover an example using a dictionary. And also kind of includes arrays too, with a API or application program interface. So basically I'll be taking JSON from an API, or the JSON that is returned from an API, and we'll pull out the information from it using dictionaries and arrays. But really the focus is going to be on dictionary. Okay, so let's go ahead and get started. So the basic syntax of a dictionary basically starts out with just dictionary, and then we have a little less than equal than sign enclosing the key value. So for keys, basically the rule is that keys have to have, or have the ability to be, I should say, hashable. Basically hashable means that the key is searchable. And so the only types that you can use for a key are booleans, integers, doubles, and strings. Alright, so let's go ahead and create our dictionary. So I'm going to create a dictionary that contains the planets. So do var, and then name our dictionary planets. And I just want to, again, reiterate that with collections, you only can use var. You cannot use a let or a constant, because constants aren't mutable. You have to use variables because they're mutable, so you can change them. Kind of useless to have a constant dictionary. Makes no sense. Alright, so we got our var, planet, our colon, and then again we're going to use the syntax defining that it is a dictionary. And a dictionary, and then we do our key value. So with the planets, we're going to have the name, which is going to be a string, and then we're going to have the value be a double, because basically this dictionary is going to have, actually go ahead and do planets, gravity. So this will basically have the name of the planet and its perceived gravity in relation to Earth. So on Earth we feel the gravitational pull as 1g. So this double will actually hold the ratio for the corresponding gravity on that planet. So we can find out what, like say if our weight, we wanted to find out how much we would weigh on each of the planets, we would hold the ratio here for the planet name. Okay. Alright, so there we go, our first dictionary. And then we can add our values. So if I actually just print out planet gravity here, it should output nothing. Basically, because we haven't initialized it or used it or given it any values. So let's go ahead and give this some values. So the first value we're going to give it is Earth, of course. And then do colon, and then whatever our value is. In this case, the gravity we fill on Earth is 1, so we'll just enter a 1. And as you see, our dictionary now has one key value pair right here, which is Earth. Let's go ahead and add another. Let's do Mercury, and colon, and the gravity or G's you would fill on Mercury would be 0.38 in comparison to Earth. And let's add another one. Let's just say Mars, why not? And their perceived gravity is... Actually, I messed up. Oh no, I didn't. Maybe I did. I don't know why Mercury would be that much. I'm going to change that. Let's do Jupiter instead. And there it's 2.528. Okay, so now you can see that our dictionary now contains key value pairs, 3 of them to be exact. Okay, and you know, there's of course always an easier way, a quicker way to do things, so I'll also show you the shorthand. So let's do another dictionary. This time I'm going to do name by parking place. So at my job I actually have an assigned parking spot, and so do my other co-workers. So let's go ahead and kind of create a dictionary with some parking places that are assigned. So again, it starts out the same way as above, but the difference here is instead of doing dictionary and then key value, whatever, we're actually going to do open and close square brackets. And then we enter in our key value pair. So for the parking place number, it's going to be an integer. And then we do colon, and then the name that is assigned to it. So we're going to do a string. And there we go. Name by parking space. Right. So it failed. Why did it fail? Variable defined here. Used before initialized. So again, that's the issue. So let's go ahead and back up. And let's go ahead and give this some values. So we do name by parking space equals, and then we're going to assign some values. So that's actually my parking space number at work. And I'll do the gentleman who parks next to me as well. It's Mike, not mine, Mike. Alright, so there we go. We've created 2 literals. Okay, so let's move on. Let's figure out how to access these key value pairs. Alright, so the first one, the first property method we're going to cover is count. So let's go ahead and do planet's gravity. We'll just count how many pairs we have in there, and we have 3. That's correct. Is empty kind of just checks to see if the dictionary is empty, so it'll return a true or false. So let's do name by parking space, and then just type in is empty. And sure enough, it outputs false. Now let's go ahead and add another item to one of our dictionaries. So there's 2 ways you can do this. The first one is with subscripting. So basically you call the dictionary that you want to use. So I'm going to do planet's gravity again. And then we begin to add the key. So we create a key because we have to have a key with a value. You just can't pop in a value. It's not like arrays where you just enter a value and just pops in at the very last, or just inserts where it needs to insert on its own. We actually have to tell it, okay, this value has a key. So let's go ahead and do Neptune. And there we go, that's our subscript. And now we need to give Neptune a value, because right now it shows that it doesn't have one. So let's go ahead and give it one. So you do equal sign, and then we enter in the gravity, or the gravity ratio. So for Neptune, it's 1.14. And now Neptune has a value. So let's go ahead and do planet's gravity count. It should be 4. And there it is. It's 4. So you can add or change a value using update value. So when I made that, let's do name by parking space. So let's go ahead and update parking space number 15. So we'll do name by parking space, and then dot update value, and then we tell it, okay, what's the new value? We're going to say it's Sharon for key. So which key is this associated with? I'm going to say it's for 15. So when we look at the dictionary now, we will see that Sharon has replaced Mike, as you see here. So there we go. That's how you update. Okay, so let's go ahead and figure out how to remove a key value pair. So with subscripting, if you notice with subscripting before, when I added it, or added the key and didn't give it a value, we noticed that it was nil. So that's how you actually also remove a key value pair. So let's go again with name by parking space, and then we tell it, okay, we want key 15, and if we set that to nil, it will, okay, error, cannot subscript a value of int with an index of type string. Okay, so I made a mistake. I made the key a string, and that's not what it is. It is actually an integer, so I should have entered 15. So there we go. And so when we look at name by parking space, it should only have one key value pair. That's what it has. Another thing to do is, instead of doing subscripting, you can actually remove a key value pair using remove value for key. So again, I'm going to do name, parking space. I'm going to do remove value for key. And since there's only one key left in here, it's 14. Let's go ahead and remove it all. And then if we look at name by parking space, it has nothing in it. Yep, so there you go. Alright, so iterating over a dictionary. So say, we have this wonderful dictionary for our planets and their gravity ratios. Let's go ahead and figure out how to actually pull those values out. So again, this is really similar to arrays, where we use the for in loop. So we go for, and then we say, okay, planet name, and then we also want the gravity ratio in, and this is where we pull in the planet's gravity dictionary, do our curly brackets, and let's go ahead and print out each of them. So I'm going to do print string interpolation, planet name, if I can spell, is, has a gravity, has of, then we do string interpolation again, gravity ratio, and do G's. All right, and so we see down here, it has output what each planet with their value. So Mars has a gravity of 3.38, Earth has a gravity of 1g, Neptune has a gravity of 1.4 g's. All right, so that's basically how you do it. And then we can also iterate using just pulling out the keys or just pulling out the values. So let's go ahead and go through that. So do for planet name, do in, we do planet's gravity, and then we do dot syntax in order to pull in the key. And so you can just type in keys. That will tell the compiler, okay, I just want the keys for these values, so these could be key value pairs. Our curly brackets, we print, so do some string interpolation. Name is in the dictionary. All right. Sure enough, it outputs Jupiter is in the dictionary, Mars is in the dictionary, and etc. All right, we could do exactly the same thing for the value. Do for gravity ratio in planet's gravity. This time, instead of doing keys, we do values. Curly brackets, we do print. Oops, print. Let's say it's if you how to say the, just do string interpolation. It's gravity ratio G. Okay. And there we have all the values that are in there. Let's have a little bit of fun. I'm actually going to go here and say has a gravity of blank ratios and you would weigh. So I'm just going to put some weight in there. So do a string interpolation, and we call in the gravity ratio and times that by how much it would weigh on Earth. So I'm going to do just 130. And it will actually do the calculation for you. So that's 130 pounds, by the way. not kilograms, that would be really heavy. Alright, and so you can see how much you would weigh on each of the planets. Yeah, by just doing a little bit of math inside the print statement. Okay, so another thing to do is you can use optionals to check to see if a value exists in a dictionary. So a really good example of this is let's see, good example. Try to think good example. Let's do users. So let's create some users. Actually, you can. I made a mistake. I said that you can't use constants for a dictionary. You can. It's just you have to be certain that you are not going to add or remove any key value pairs. So basically you can't modify it at all. So you can use it, you know, and it will still behave just like a regular dictionary that's a variable, but you can. So, yeah. I don't know exactly what you would use it for, but who knows? Maybe you would have a reason to. Alright, so let's go ahead and create a dictionary of users. So I'm going to say var users. Let's do B. Smith, and his name is Bob Smith. And then let's do S Max. Can't think of anything right now, so there we go. Do Steve Max. Okay, so I don't know if you noticed that what I did here is I actually had Swift infer what this type users will be. If we do option plus click, you can see that it's a dictionary. So Swift is smart enough to realize that if you add any syntax like this that resembles a dictionary, it's going to be a dictionary. Alright, so there's also inference. Okay, so let's go ahead and create another variable. Let's just do a constant that says, hey, let's have Steve equal, we'll have the type of string. And this string is actually going to be a optional, because we don't know if Steve is actually in the dictionary. We're going to pretend like we don't know. And then we're going to say equals users. Then we do S max. Okay. So if we're going to do if let, so we're going to kind of check and end unwrap if Steve actually exists, or this particular user smax exists in the dictionary. So if let user equals Steve, so if it does contain it, then user is going to be the value of Steve. I'm going to print out string interpolation, user is in the dictionary. Okay, and sure enough, Steve is in the dictionary because we did add it. Alright, so we have covered basic dictionary syntax, how to create dictionary literals, longhand and shorthand, accessing, modifying our dictionaries, removing the pairs, iterating over them, and using optionals to check the existence of a value. Alright, and if you are interested in seeing an example with an API, go ahead and hop over to that video.